four important aspects, which we feel is covered majorly in all of the CISSP exams. So this domain carries 10% weight within your CISSP course, and some of the subdomains within this domain are understanding the software development lifecycle, understanding how the ecosystem within the SDLC look like different tools, different patterns, different methodologies, uh, and also understanding a little about different testing platforms like SaaS test, etc. Uh, and then understanding the effectiveness of software security, like the importance of auditing, importance of risk management, risk analysis, etc. And then there is a small element of third-party software as well. So what do you do when you have a lot of presence of third-party software in your company, and how do you manage those? And then finally, ensuring the software development best practices, software security best practices are well known across your organizations through trainings, etc., and also through secure coding practices, uh, etc. So today we're going to cover some of these aspects in detail. This list is an exhaustive list. We may not be able to cover each and every aspect, but whatever we feel is really important for the CSSP course, we've covered them here. And also I'll give you some references where you can further go and look for some of these details in detail during the course of the session. So let's start with understanding what is SCLC and SDLC. I think this is a very basic terminology, which I think everybody understands this. SLC means system lifecycle. System lifecycle is a very holistic approach where you have an entire development of a particular software, rolling out of the software, making it live, and then taking over, giving it over to operations where there is BAU activities going on day to day. And then at some point when we feel there is no need of the software anymore, we ensure we dispose it safely and effectively. So that is a life cycle of an entire system. And in general, when we look at a system life cycle, it is followed across every organization. For example, there are a lot of softwares which are going to be end of life or end of support, right? In those scenarios, you tend to dispose them, or you create a different version of that software and then launch it, and then you slowly start deprecating the older components, right? So that is the entire life cycle of system life cycle process. And SDLC, software development lifecycle, is a small subset of system lifecycle. For example, you all know SDLC has multiple stages where you initially start planning, right, and understanding what needs to be built, and then you start gathering requirements from different stakeholders, different personas. You try to understand who are your user groups, who will be using the software, who will this be beneficial to, who are the key stakeholders of the software, who will be responsible for maintaining it, who will be responsible for ensuring it is completely available, etc. So you kind of try and gather all the functional non-functional requirements, and then you start doing your design stage where you understand how to build the software, what are the different architectural best practices to be followed, how should your design look like, etc. And then you start getting into the development aspects where you start actually coding your software, and then you have a testing phase where you have your entire quality teams testing your software. There are multiple different test scenarios, multiple different test paths that you would expect the QA teams to test, and then finally you plan for your release and deployment. I think this is a very standard SDLC approach, which everybody would be aware of. But then the important aspect to understand here is how do you ensure there's a fine balance between addressing the requirements and ensuring there is a very good user experience that you're providing in the software, and also making sure security is embedded right from the design stage itself, right? And how do you balance all of these three traits? That's important. Um, so in your CISSP, there could be questions around, there could be scenarios where uh, they'll give you a particular scenario and they'll ask you to pick a trade-off. Would you pick a trade-off between security, user experience, or functionality, right? You should be able to understand the question and understand what needs to be done in that particular scenario. So just for that, a small tip is to understand what are the different mechanisms through which you provide a trade-off between security, functionality, and user friendliness. So understanding that is important. So moving on, I think when we slowly dig down into SDLC, we have well-known soft methodology, development methodologies like waterfall, agile, spiral, etc. I think most of you are all familiar with these terms. I don't think I have to go in depth into any of this. As we all know, waterfall is a very uh, conventional and traditional methodology which was used way back. Right now, companies have already moved away from waterfall, but then there are still few companies which still use waterfall because of some of the legacy reasons. So I think this waterfall model involves doing everything at every step. Like you gather requirements. Once that phase is done, then you do the design. Once the design stage is done, then you move into implementation, followed by testing, deployment, and then operations, maintenance, BAU, right? Everything happens in a sequential order, step by step. So that is how a waterfall development methodology is defined. And moving on to spiral, taking inspiration from waterfall, the community decided that this will not scale because the rapid development of software will not happen in the waterfall model because uh, in the waterfall model, one of the things that you expect is that you have all of your requirements defined at the initial stage of your project. You have your design figured out. The design should be accurate. Design should be ensuring it covers all of the different scenarios. Your architecture should be solid, and in the waterfall, you don't expect any change throughout your development cycle. Once you've freezed a particular design, it's freezed until the software is shipped. So that is one of the downfall of waterfall because there is no scope for changes in the scope, changes in the design, any change based on feedback, right? There is no scope for any change in the entire development process. It's freezed and you have to ship whether we like it or not. So that's the downfall of downside of waterfall. And because of that, community started adopting to something called a spiral model, where you can do a lot of iterations of the same software. For example, you build an initial version of the software, and then you can go back to the requirement analysis, do a detailed requirement analysis to understand, does the initial set of requirements hold true? Do we need to add more requirements to it? Does the design at the initial stage holds true or holds correct? Or should we add additions to it, modifications to it? So that way, spiral model is an advancement of over waterfall. It gives you a flexibility to go back and revisit all of the different stages and refine it. Um, but spiral model takes a risk-based approach. So in this spiral model, what happens is you tend to understand what are the risks associated at every stage. For example, for a particular piece of software is developed, you understand what are the risks associated with that piece of software. Considering the risk, prioritizing the risk, you build uh, another feedback loop around it to address that risk. So the main goal of spiral model is to understand the risk that is developed in the first release and fix those things in the second release. Likewise, understanding again in the second release and then fixing it in the third release. It takes a risk-based approach. Um, but it gives you a flexibility of revisiting every stage at a particular time frame. So based on this spiral model, uh, another model got very famous, which is agile, which is predominantly followed across all the organizations. Spiral model is a very theoretical model. It did not have the execution mechanisms of how it can be executed, how it can be adopted in various organizations. That's where agile model it came into picture. And with agile model, there have been a philosophy that was defined based on which agile model is defined, and then there were there's something called an agile manifesto that was built, which consists of 12 principles. uh, and for the purposes of CISSP, you don't need to remember all 12 principles, but in general, having an understanding of what are those 12 principles based on which foundation methodologies the agile is built, it will be helpful just to answer a few set of questions within the exam. And then, like I said, the one of the interesting piece of agile is taking user feedback. So it is an iterative approach where you tend to do small amount of work, right? And you tend to release that amount of work and gain instant feedback. Based on the feedback that you've received from the end users or from the stakeholders who are using this application or software, you tend to incorporate that feedback in a rapid manner, again in a very short span of time. So that is how agile methodology works. Uh, there are multiple terminologies within agile methodology like sprint. A sprint is nothing but a set of tasks that you complete within a particular time frame, a time bound time frame. Generally, companies adopt a 2 week sprint or a 3 week sprint. Within that sprint, you tend to incorporate some functionality to the software and ship it immediately to the production, and then gain instant feedback on the shipped product or the shipped functionality, and then immediately incorporate the feedback. This way, the software development happens rapidly and also efficiently with good results because you're getting feedback and you're incorporating the feedback very frequently, as against waterfall model where you cannot touch your software once the requirements, design, and development is freezed until you ship it, and then you have to revisit. It's going to take significant amount of time to upgrade your software because you have to go through the entire process all over again. With Agile, you have the flexibility to break the entire software functionality into multiple small chunks and apply the waterfall methodology for each small chunk, like doing requirement analysis, design, implementation for every small functionality. That way, it is built in a very decentralized manner without the need of having a single requirements and design across. But rather, you can have multiple teams building the same software with multiple different uh, steps, and by using the same requirement gathering, design, and development at every stage of the software. So that is the advantage of agile. And some of the one of the things that we need to remember is what are the different methodologies within agile, like Scrum, Kanban, RAD, AUP, etc. So just getting an understanding of what are these will help in your exam. Most of the exams question does not ask directly on these, but they may give you a scenario and they may ask you uh, which agile methodology does this particular scenario fall into. That way you will be able to understand the scenario and then map it to a specific answer. So that's about agile. Yeah. So any questions so far? I can just quickly pause for a few minutes to see if you have any questions. Okay, I take that as a no, so I'll move forward.
Question here. I'm Raj here. I just joined. Sorry, I was struggling to get hold of the joining link. Just on these agile methodologies, what is the most current having, which is, with the emerging AI and, with all these different development methodologies in generative AI and generative code that way. So how is it working together with the AI, and which is a methodology which is pretty much supporting it? And are we seeing any difference from what we were doing and what we should be doing currently or in future?
Not really. I think earlier to AI revolution, we still used Scrum and Kanban predominantly across. Even now, this I mean, even with AI, the software development methodology has not changed. It remains the same. Just that you're using more automation, more AI agents to build these kind of things. But then the primary foundation of developing the software still remains the same, because the agents still have to be built and developed, right? Um, while your agent does things for your activities, but then the agent has to be still built. And building the agent are still for building the agent, we are still using the same Scrum and Kanban, which are predominantly used across. So nothing significant has changed, but then we'll have to see, wait and watch if something will emerge in future.
Okay, thank you.
Okay, great. I'll move forward. Yeah, so there has been a great shift in the past 10, 15 years, where everybody thought security is very important, and they thought security is predominantly should be considered at every stage, right from the initial stage where you start planning to build a software itself, right? So security by default is the trend, and uh, secure by design is another trend, right? So secure by design is a term that got very famous because at the design stage itself, you have to embed security into your entire planning, etc. Right? So that's when people started moving from DevOps to DevSecOps, where you have an entire CI/CD pipelines that are built, considering security also into picture. So that's the shift that has been taken over in the last 10, 15 years. And right now, every deployment, every software development happens with DevSecOps in mind. No software, I think predominantly no software is released without having security testing done in your entire CI/CD pipelines. So basically, what happens is at your requirement stage, there are functional and non-functional requirements. Functional requirements are very specific to how your software should function, but there are something called non-functional requirements where you talk about what you talk about security, you talk about availability, and right. So when you talk about security, you start capturing requirements such as, hey, my software should always communicate with external world using a TLS encrypted channel, right? That is one of the non-functional security requirement that every teams are embedding into the requirements list. Likewise, people are gathering all the requirements at the security requirements at the stage where you're actually finalizing the requirements, and then going into the design. And while you're at the design stage, the design is and the design is done ensuring all the security aspects are covered, right? For example, how are you storing your secrets? Are you storing your secrets in a centralized key vaults? And are you hard coding the secrets in your code, right? So that is the design decision that people are taking, saying that, hey, let's move and externalize the secret management. And some of the other security decisions that have been taken are, hey, how do we automate the entire life cycle of our identity? How do we ensure that all our security keys are rotated? How do we ensure that the data at rest and data at transit is encrypted, right? How do we ensure that the entire certificate lifecycle management is automated? So all of these decisions are being taken at the design stage, and then the software design is appropriately designed considering all of these aspects. And then at the same stage, there is something called threat modeling that's been done widely by every organization. There are various methodologies of threat modeling, like dread, like pasta, etc., which we will cover in the later part of the session. But threat modeling is an activity where you tend to understand your threat landscape, your application, what are the different entry points to your application, uh, what are the different interactions of your application with different systems, and then you try to understand what are the different risks that you see as against the threats that you see in the markets, right? And then we also try to understand what and vulnerabilities can be exploited by threat actors to basically compromise something. So that is a kind of activity that is needed to be done at the design stage, which is called threat modeling. And there are quantitative and qualitative methods to do this threat modeling, which we will talk a little bit in the later part of the session. And then when we start developing the software, when we start coding the software, the entire CI/CD pipelines are having automation, where automated security scanners such as SAST and DAS scanners, which can look at your deployed developed code, identify weaknesses in the code, and then also do a simulation of some attack paths, which a real attacker would do, understand if your application is prone to those attacks, and giving you back a feedback saying that, hey, this is the weakness that I see, go fix it. This is the recommendation. So every CI/CD pipeline nowadays consists of the SAST and DAS scanners, and also uh, a lot of companies are also publishing their SBOMs. SBOMs are nothing but software bill of materials, which is nothing but a list of all the open source and third-party libraries that have been used in the software. Uh, Having an inventory of all of those is really important, because not every vulnerability emerges because there is a flaw in your software that is been built in-house, right? There could be a flaw that is been there in a third-party software that your software uses, and because of that flaw in the third-party software, your software is impacted, right? So having an understanding of all the different libraries, all the different uh, external sources that you use to build your software is important, because you can keep a track of what CVEs or vulnerabilities are emerged within these softwares or within these libraries, so that you can upgrade to the latest version that is published by the vendor, or you can ensure there are mitigation controls that are put around it. So every pipeline now consists of SBOM scanners, SAS scanners, DAS scanners. All right, and then at the stage of once the release is done, once the production is done, and then you probably also have a real-time monitoring of your application, right? For example, if there are any, once your application is live, are there any threats that are coming into your platform? So that's when the entire EDRs of the world, that's when, where we have threat detection mechanisms in place, IDS, IPS in place, to kind of understand if there are any attempts of threat activity going on your application. So that's where the entire monitoring piece comes in picture. So this is the entire shift that has been taken place in the last 10 to 15 years. Nowadays, every organization have these mandatory tools, SBOMs, scanners, SAS scanners, DAS scanners, uh, and then your a SIM solution where all the logs get fed into, and then uh, threat detection use cases built on top of it. And then on top of that, you also have real-time threat detection mechanisms, like famous ones are with being safe, etc. So this shift of moving from DevOps to DevSecOps has predominantly taken place, and now applications are built with much more secure by design uh, mindset, and every engineer or every developer is adopting this mindset while they're building the software. With this, I will stop for a while, and then let's take a small quiz to understand. Uh, to understand how CISSP questions can be asked. And please note that this is not an exact simulation of how a CISSP question is asked, but then it is just a starting point. So let's dive into this question. So Charles is developing a mission critical application that has a direct impact on human safety, and time and cost are less important than correctly functioning software. So which of the following software development methodologies should he chooses given these requirements? So keep in mind, the question talks about time and cost being less important, rather software functioning correctly is important. So with this caveat, what software development methodology is relevant for this kind of a scenario? Anybody would
Waterfall
like to?
model.
Yes. Any other suggestions? Yes, you're right. It's waterfall model. If the requirement is, hey, I have a strict constraint on time and cost, or maybe time, but then my software can be improved progressively. If that is the line that you see in the question, then the best bet will be agile. But because of the fact that the time and cost are less important, waterfall is appropriate here. Moving on, Chris is a software developer and is actively writing code for an application. What phase of agile software is in? Anybody?
Development.
Development.
So keep in mind, this question is a very tricky question. You'll have to read between the lines. So I will ask you to read the question again. So the key important aspect is agile here.
I guess then it's sprints, right?
Exactly. That's right. Right. So because of the fact, see, planning, development, and deployment are very generic terms. But because of the fact that this question uses the word agile, the relevant, very a close answer can be sprints here. So that's how we'll have to do an elimination and then understand what can be an appropriate answer. And generally in all of the CISSP exams, uh, you may find all the four answers to be correct. But the key is picking what is the closest answer to the question. So that is when we'll have to do some elimination methods, read between the lines, understand what keywords and words are being used in the question, and then see what fits well to the options. So the answer is B, which is sprints. Moving on, uh, which one of the following principle would not be favored in Agile's approach to software development? So I'll read the question again. Which one of the following principles would not be favored in an agile approach to software development? The options are here. I'll leave the screen here for a few minutes for people to read. Anybody
Customer
who wants to.
satisfaction over contract negotiations.
AI.
Okay, one of the answer was C, and somebody said A. Did
Yes.
anybody say A?
A.
Okay. Anyone else?
I'll go with A.
Okay. Okay. The right answer is A. So if you read the Agile Manifesto, right, one of the fundamental aspects is the importance given to uh, people and their interactions, right? Uh, over the process and tools, because agile mainly follows agile is a super hit because of the fact that some software has been developed rapidly in a very short period of time, but then it is released, then you gain feedback from the stakeholders, from the people who are using the software, and understand what could be improved, what can be improved, right? So based on the feedback, you tend to improve the software in a progressive manner. So that's where interactions with individuals is more important uh, than other aspects, right? Okay, moving on. Uh, so I'm sorry, I'm moving a little faster because looking at the time, and I want to have more time reserved for most of your questions. So I'm going a little faster. If you feel that some topic needs to be revised or maybe we want to discuss a bit more on it, please feel free to pause me there. And moving on, there is something called maturity models, software development maturity models. Uh, These are very theoretical things, and if you read the original CSSP guide, the long book that you have, a long list of security models are called out, and a lot of information is present around these details. It is a good to know kind of information than must to know kind of information. So, but then because it's good to know, let's brush it a little here and there and then move past this. So there are multiple maturity models. One of the maturity model which is defined by OASP is SAMM. Uh, it is Software Assurance Maturity Model. It is an open source framework. Basically, it has like 5 pillars, which is governance, design, implementation, verification, and operations. And under each pillar, there are various levels. Uh, the first one is the first level, second level, third level, right? Uh, so based on these maturity levels and at every pillar, this maturity model is used to understand the maturity of your SDLC process. For example, when a third party auditor or a third party uh, auditing company is understanding or trying to do a maturity assessment of your SDLC process, then they would use some of these models to basically rank your SDLC maturity. So this is one of such model that is used. So in the governance pillar, basically one of the fundamental aspect that that is expected that every organization should have is training and awareness, organization culture, ensuring. So what it means is every company should be having a mechanism or an initiative where the organization widely communicates to every employee of secure software development practices, secure coding standards, what does it mean to develop a secure software, and then what are the implications of developing a non-secure software. So that is the kind of education and awareness that needs to be provided by every organization, to every employee, or to every engineer who is working on various projects. And then on top of that, that is the level one. So if you have this, then you passed your level one. And then beyond that, if you have strict policy and compliance measurement, where you have a list of defined policies, for example, what is your policy around when somebody asks you, what is your policy around vulnerability management in your company? If you are able to explain your policy saying that, hey, my vulnerability management consists of this different steps, this is the SOP, this is how it is defined, etc., then that means your company is in a mature level, right? And then compliance management is a process where you tend to regularly, periodically verify whether all of the different controls that you put in place under the policy, right, are being used actively by every employee, are being followed, all the processes are being followed as appropriate. And if there are not followed, then you raise a red flag. If they're followed, you put them in green and see where you can improve. So that is the kind of management that needs to be done by every organization. And then gather metrics to report to the steering committees, to the executive board, board members, to basically give them a perspective of how your maturity around your entire software development looks like, right? Are there gaps that needs to be called out to the executive leadership team so that they can necessarily fund and ensure those gaps are mitigated? And then at the design stage, it is expected that every company should have a security architecture review done. The security architecture review would include a detailed assessment of how your software is being built at every stage, and and what are the different components of your software, and does each component of software is built by keeping security by design in mind? Is it built with all the security best practices? So that is a kind of an an assessment that needs to be done by the architects of the entire company or the projects. They'll have to actively assess your strength of your application in terms of security. And then, do you have a list of all the security requirements that needs to be met, listed at some place? That is another important maturity level that every company should follow. Uh, do you have them documented? What is that document used as a reference by every team, every developer as a reference when they're building the software? That is kind of an important aspect to note while you're actually building your ramping up your SDLC process within your company. And then there is a small aspect of supplier security to this. Supplier security is nothing but it's an assessment done on all of your suppliers, whether they are meeting the security needs that needs to be met, right? For example, you are using a jQuery library, or maybe a library that is built by a particular company. If you are using that library, you will need to assess whether that company is using all the software development lifecycle methodologies to build that library. Is that library being actively scanned through SaaS, DAST, etc.? Do they have a patch management process in place? Do they perform a threat modeling activity when they're building that software? So an assessment on the supplier is nothing but the supplier security assessment. This also is important aspect in every company, usually done by governance, risk, and compliance teams when they're onboarding a software into a company. And then the most advanced maturity level is understanding your application, breaking down your application, doing a threat modeling activity of your application, understanding different risk profiles, and finally getting to a place where you understand what is your business impact if in case this application is compromised, and also understanding whether your application or a software is a mission critical workload or an business critical or a task critical workload. So understanding that is an important aspect of this threat assessment. Finally, then going on to implementation pillar, you have defect management, which is very standard, which every company has it. Where do you log all the issues, right? Do you log it at a central place where everyone gets some visibility over it? Do you follow a process where you fix the defects as per the SLAs that you have defined within your company? Every company has their own SLAs in terms of fixing a particular issue. For example, if it's a high severity issue, you fix it within a specific time of, like, say, 15 to 30 days. If it's a medium severity issue, you fix it between 60 to 120 days. If it's a high if it's a low severity, then you fix it between 120 to 180 days. So every company has their own policy. Every company will have their own SLAs defined. So ensuring you have a proper way to track all of these issues, and in the tracking, you should ensure that what is the severity that's captured and what is the remediation date that you have. So that is defect management process, whether you have it and whether it's actively followed is an important aspect to be noted here. Likewise, you have secure development, secure deployment, like what is the process in which you deploy the software, right? And then whether you're using some of the best practices such as secret management, certificate lifecycle management, PKI, using a PKI, automatic PKI infrastructure. All of this falls into secure deployment process. And then secure build process is a fact where is the process where you ensure the entire build process is well defined and taken care, whether you're doing SaaS scanning and all of that, whether you are pushing the software to the right repositories, whether you're pushing your softwares into the right environments. All of those falls into the secure build, and ensuring if there are any software dependencies that needs to be covered. All of the dependencies are resolved at the stage of build, and all the dependencies are pulled from the trusted sources where you have integrity checks that have been done prior. So all of this falls into the secure build stage. And then moving on to the verification, that's where you do testing. This is a test where you do a pen testing, vulnerability assessment test, vulnerability scans, etc. And then moving on once the testing and verification is done, once you think your application is good enough, it's secured to the expected levels, then you kind of go into the other side of the operations where you see whether you have is logging of all of the security events done at a single centralized place, whether you have ingestion of those logs and events into a centralized SIM, whether you have use cases built on top of those based on the MITRE attack or different frameworks. Those kind of things comes into picture, and then you are also doing regular hardening and patching of all of your vulnerabilities on or all of your infrastructure, because infrastructure tend to age, right? When new versions emerge, the old versions will have some vulnerabilities which are unnoticed, which if it's not noticed and if it's not addressed, they can lead to an attack path. So ensuring you have a hardening program in place, a patching program in place, when ensuring you have an hardening and patching life cycle around it, and then you have a policy around end of life, end of support software. How do you deal with it? How do you dispose it? All of those aspects have to be documented, and you will have to have uh, a proper process to follow them. So this is the entire maturity model. This is used when you are assessing a SDLC maturity in any company. Likewise, there are multiple other models like CMMI, but CMMI is a very it's for software development. It's not actually taking security into consideration. It is basically uh, a maturity model that is widely used again by all of these different auditors, but they don't exclusively look at security. You'll have to bake in security into the CMMI model. Both of these models are widely used. But if you're seeing like big fours like PwC, Deloitte, etc., they predominantly use CMMI, and then they bake in security aspects into it. So that's about these maturity models. Understanding all of these aspects is really important in your CISSP. A lot of questions may come around these aspects. They give you a scenario and then they ask you what could be the next potential step that your team has to do in terms of doing a matured secure software development. So those are the kind of questions and scenarios would be asked in a CSSP, and understanding this overall maturity model kind of gives you that ability to understand and interpret the questions. So that's about maturity models. And then once the entire software is developed and once it is shipped, once it is deployed to production, that's where the entire maintenance and operations comes into picture. That's when another different team takes over, right? Usually the software development teams do not do support, so you hand it over to support. When you hand it over to support, there are a lot of things that needs to be considered, whether the support teams are empowered enough to understand every bit of the functionality of your application, right? Whether do they have an SOP around handling different types of issues that emerge in your software. What do they have to do when a particular type of issue occurs? What are the different steps that they have to follow in order to debug that, in order to resolve that, etc., right? These are the different SOPs that needs to be defined when you're handing over your software to an operations and maintenance teams. And the main responsibility of these teams is to ensure that this entire software continues to run 24/7 without any interruptions, without any downtimes. And then there is an element of monitoring and incident response, uh, understanding what kind of, so basically looking at your entire application from an infrastructure and from an application standpoint, and understanding what are the threats that you have, what are the different malicious activities that are happening on your application, ability to detect them, ability to handle them appropriately, ability to do and ability to kickstart an incident response process is the important aspect when your support teams are doing it, or when there is a SOC team usually in every company who does these kind of things. So working with SOC teams to ensuring what attack paths that they need to look at, what are the different sources in which this application can be compromised, and these are all the inputs that you can get from your threat modeling activity. You've already identified all the different attack paths. Working those attack paths with your SOC engineering teams to basically understand where to how to write a detection logic for those, how to basically ingest logs, what kind of logs need to be ingested, and how do you ingest them. Those kind of things need to be figured out. And then the regular process of vulnerability and patch management. You have your runtime threat detection engines running 24/7, understanding different vulnerabilities, capturing and identifying different vulnerabilities. And once you identify those vulnerabilities, you have to define an SLA around those vulnerabilities. Again, for high severe, medium, low severity, you'll have to define SLAs, and based on the severities, or based on the SLAs, these vulnerabilities have to be patched, and having automated patching solutions in place, making sure the patch is working appropriately, which tested in the lower environments, then migrated to production environments is an important aspect to be considered. And then again, change management, configuration management, etc. I think these are all standard things that every support operations teams they usually do it. So ensuring all of these processes are maintained, done well, and audited frequently are crucial in terms of achieving maturity in your software development process. Okay, I'll stop for a while here just to check if you have any questions.
Yes, I have a question, unless if somebody wants to ask.
Yeah.
So basically, I'm not sure where it fits in, but basically nowadays most of the software development happens in India, or in the South Asian countries, and then if it's for an organization that will be implemented in say in US, in that region, North American region, and then what is the process as regards the whole SDLC is concerned, what in terms of maturity models, in terms of the development process, testing and implementation, and also most important in terms of security, what needs to be considered so that when it's implemented in the North American region, it's good to go, kind of. So I'm just framing the question in that way, but I hope you understood
Yeah.
that. Yeah.
Yeah, I got your question. So let me take this. So every every country will are bounded by their own laws, right? So, for example, there are some regulatory laws that needs to be adhered to. For example, if you're selling a software to a federal customer, or when I say federal customer, anybody who's operating in the federal arena of the US, right? Like the Homeland Security, like the FBI. If you're selling a software for them, or if they're using a software that's built by you, then your entire software development mechanism has to adhere to a lot of controls. For example, one of the control that they have in place is their data should never leave US boundary, right? Without prior consent from the FBI authorities, or from the federal authorities. So ensuring when you're developing the software, you have to ensure that your data centers are always located within the US, and you're storing your data only within the US. You're not crossing the data outside the US. So that is an important criteria to be considered. So again, it depends on the regulatory. So the FedRAMP is the program. FedRAMP is the regulatory body which looks at these kind of controls to ensure that any software that's been sold to federal customers are having these kind of controls in place. And one of the important consideration for FedRAMP is that you also have to, any software that you use to build the software, right? For example, the IDEs that you use, the SIM that you use for security monitoring, or the SAST and DAS tools that you use for scanning your products, all of them should be FedRAMP certified. You cannot just bring an open source software, plug it in the pipeline, and develop a software for federal customer. So that is again not accepted. So there are certain rules and regulations that needs to be followed, and you have to adhere to based on the regulatory authority. And similarly, if you're developing software for European customers, right? If you're building a software for Europe region, they'll have to ensure that GDPR guidelines are maintained and followed, right? You'll have to build a software in such a way that you give flexibility for the users themselves to delete their personal information from the software, right? They should be able to request for not storing a
Sorry,
particular snapshot.
just yeah. I mean, I was actually asking in terms of, I mean, regulatory and privacy. I understand. I was only asking in terms of technical aspects as regards security is concerned. So what I'm asking is in terms of the development and testing part of it, and then you're actually implementing it in say the US region. So, what kind of like protocols or in terms of the firewalls and things like this? That's what I'm looking. So to make sure that this we are taking this particular piece and then we are now implementing there. So once it's done in, I mean, once it's implemented in US, so basically it has gone through all those checks that it is good to go. So what is I'm asking in terms of the technical aspects, like whatever goes into it to make sure that it's so that kind of environment or secure environment was actually created virtually here in India, and it has been tested from start to finish.
So generally, when you think of traditional software development, right, nothing changes from whether you're building the software in US, whether you're building it in India, right? The software security development principles remains the same. From a technical implementations also they remain the same. But the choice of what products you use to test and develop these softwares depends on whether you are bound by any federal regulations or whether by any regulatory authorities. That's what I'm trying to say here. But then the software development methodology with all of the different processes, procedures, and the technical implementation will remain the same. You don't build a software in India with less secure firewall controls, right? You would want to build the same level of sophistication that you would build for you would do while you are building a software in US. So that from a technical implementation standpoint, they remain the same. But from ensuring the data security, privacy standpoint, you'll have to consider certain things and ensure that your design includes those aspects when you're building some softwares from federal or some from for some regulatory uh, prone bodies.
Okay.
Any other questions?
Yeah, maybe I'm not sure, but I was thinking in terms of IP and other things also, like perhaps more on that aspect, like the secure layers and IP and things like that. So, I mean, I need to deep dive into that area. So, yeah, so I probably check on that. Thank you.
Definitely. To your point, IP is also the same for everyone, right? It doesn't matter on the country. For example, if a company is operating in India, their IP is as important as a company operating in the US. So generally, when you have to do an IP protection, you build a secure zone and you ensure that all the people, all the software developers are building the software only in that secure zone. That it's called a green room where you don't allow any of your gadgets inside. You are regulated. You have to take some trainings, etc. when you enter into it, right? And then the software never crosses a particular boundary. It always remain within the localized versions. It doesn't go to cloud. It stays on premises. So there are various controls that you put in place depending upon how you want to protect your IP. But then it is not based on country, is what I'm trying to say. It's based on what is the impact that you see if your IP is leaked. Who is going to be affected? If based on the IP leakage, if the affected customers are federal customers, then you have to ensure that federal laws are applicable and all the federal controls are incorporated into your development lifecycle. But if your customers are European end users, then you have to ensure that you have GDPR kind of controls already baked into your development and design stages. So it depends on the impacted people, impacted personas or impacted people rather than where you are building the software.
Okay. Thank you.
Okay. Moving on. Yeah, I think everybody knows this, right? A software development ecosystem consists of people, process, technologies, right? Um, Processes are nothing but the SDLC, DevOps, CICD that we've discussed so far. And then technologies are what tools that you're using, what repositories that you're using to store your code, etc. And then various environments and what different, how do you segregate different types of environments, etc. So when you're securing your development pipeline, what are the different stages of your development pipeline is something that is important to note. Uh, when you're building a software, it is the software is not just a piece of code that you write, but it also involves a lot of aspects. For your software will have to be deployed onto an infrastructure. You also have to consider not only the code security of your software, but also the infrastructure security where your code is going to be running, right? So, and then you should ensure that this infrastructure, when it's talking to another different components within your infrastructure, that those communications are also secure. And in all of these things, you should have a visibility around what's happening in your entire network, like who is coming in, who is going out, what are they doing, what kind of activities are they doing, are they doing anything malicious, do we have a way to identify if something malicious has been done. So all of these things need to be kept in mind when you're developing an end-to-end pipeline. So that's when at the left side you see secure design and architecture. That's when you start building your application. You understand what features to be built, and you have a list of all the requirements, and you also have written down all the security requirements that you want to bake in, and then you do an extensive threat modeling, and then you kind of understand after your threat modeling, what are the different risks that are associated with this particular piece of functionality or with this software, and then you look at all your different security requirements and security requirements and see whether I'm fulfilling all of the security requirements that would address the so-called risks that I've identified in the threat modeling activity. So that kind of assessment needs to happen. This is purely a manual assessment that happens, and then you move into the secure coding phase wherein you have various branches within your code repositories. You have a feature branch. Once a developer writes their feature, develops the feature, they test it using their feature branch. Once they think they're good to go, the unit testing is done, they're good to go. Then that is when they do they raise a PR request, right? And this this merge request is sent to one of the architects or the lead of the project, where that person reviews the entire reviews the entire code base, and he certifies and say, okay, this is good to go, this can be merged. And then that piece of code gets merged into the actual code base. Once that is done, but if the lead or the security architect thinks that this is not well written, this needs to be further improved, that can be the PR can be rejected, and it goes back to the developer. The developer again reworks on it. But if it's good to go, it gets merged into the actual code base. It gets merged into one of the other branch which is used by all other developers to merge changes in, like the dev branch or something. In that branch, you basically do a SAS scanning, SCS scanning, to identify any sort of static code vulnerabilities in your code. And then once you're good there, you can then your pipeline moves into a packaging stage where your code gets built into a executable binary. It could be a WAR file or a jar file, or it can be an exe file, depending upon the type of application. It kind of or sometimes what happens is you would also build a Docker image, right? If you're a Dockerized environment, you would build a Dockerized image. So all of these binaries, whether it's a Docker image or any other type of binary, you can store them into a binary repositories, and a scan can be initiated on that repository to check if there are any vulnerabilities in the entire binary, right? For example, especially if you are building a Docker image, when you're building your code, you may use a Docker image, Docker base image from some well-known open source repositories. But that open source repositories may contain some kind of vulnerabilities. So when you actually build a Docker image, you run a scan against your Docker image to identify any sort of vulnerabilities that are present in that image, right? And based on that vulnerabilities, you kind of fix those vulnerabilities and then redeploy your image. So that is when container image scan is important, especially when you're building Docker images. And then once your packaging testing is done, your application gets deployed into one of the lower environments. That's when the entire DAS scanning happens. DAS is nothing but dynamic application security testing. In this, there are several rule sets within the DAS tools. All of these rule sets basically simulate an attacker actions. They try to generally how an attacker does to attack or break a system. The same set of logic is present within the DAS scanning rules. Those rules are against executed against your application to check if your application is prone to any of those attack paths. If that is good, then your artifact, which is your entire deployment, is published to an image repository where you can actually do an integrity check, integrity signing on your repository. So, for example, let's say you've built a software, you think the software is in a very good shape, you then can sign that image using checksums or any sort of integrity checking mechanism. You can sign the software, and then when somebody is using the software, they can verify the signature to ensure there is no tampering that is been happened and the integrity is maintained, right? So the signing can also be done. And then yeah, once then if you're actually doing a Kubernetes kind of orchestration, you can basically use the signed image. You can pull the signed image into the cluster and then spin up the pods, and your application is live now. Once your application is live into production using all the using this infrastructure, you can then also include some of the runtime security scanning tools. For example, if you're using any kind of Kubernetes runtime security scanning tools of like Lacework or Wiz or anything like that, you can have a daemon set installed in your cluster too, which can look at all the process activities that are happening within your application. So all of those threat activity can be monitored using this runtime threat detection kind of an applications or systems or services. So this is the whole list of pipeline. And throughout this, one horizontal thing that needs to be maintained across is how do you ensure secrets are maintained and managed? At every stage, you need secrets for a lot of things. For example, your dash may need some secrets to simulate test against your application. Your when an image scan happens on the registries, you would need credentials to that registry stored somewhere, right? All of these things, all of these secrets and credentials should be handled centralized in a they should be handled in a centralized manner in a secret management solution, and they have to be fetched in runtime in order to be able to access those systems. So this is the entire software development pipeline. Uh, any questions on this? I am happy to answer because you can expect a lot of questions around this.
Maybe you can just put some light on the fuzzing part of it on stage and test.
Yeah, okay. Fuzzing is again, so it is like testing it using, or how would I say that? Fuzzing is a mechanism where you uh, test how does the software react in case you give some inputs and payloads which your software is not expected, right? How does your software react to it? For example, if your software is only expecting a JSON payload, what happens if you give an XML payload, right? Uh, does it react violently? Does it crash? Does it throw back a stack overflow or stack overflow message back, revealing a lot of information about your application? So that is a kind of test that is done in this kind of test. You can, I mean, you can research a little bit about this. You'll find more
Okay.
information around it.
Hi, Shri. I'm Lokesh here.
Yeah.
Just wanted to check on the SAST and DAST. What is the main difference between that?
Yes.
Dynamic and static, okay, but yeah, can you please help me out?
Okay, sure, definitely. So static code analysis works based on your code. So that scanner looks at your code. It goes through your code line by line, and it can look at, and it will spot and identify some weaknesses in the code. For example, the common mistake that every developer do is when they're storing some information in the database, they don't use prepared statements, right? They just hard code the entire data in the same SQL query, in the same string. So that is a very bad way of doing it. The best way to do it is using prepared statements where you cannot inject any malicious scripts into it, right? Using SQL injections, etc. So a SAT can look at those code, and it can identify such code issues. So it is very static. It does not look at live functioning of your application. It just looks at your code line by line and identifies such weak lines of code, and it is lag errors saying that, hey, this line of code has this error. Uh, an attacker can exploit this particular thing to basically compromise using an SQL injection or something. Or but another example is when you are actually storing some files in your infrastructure, you kind of give an absolute path. Sorry, you kind of give a relative path using dot dot slash, and then you put the file name somewhere, right? So that is prone for directed traversal attacks. So your SAS scanner looks at those kind of weaknesses in the code that you've written and flags it. Whereas a DAS scanner runs only in your on your application that is working live. So once your entire application is deployed to a lower environment, so in this entire stage, the SAS scanning happens, the packaging happens, then you deploy the code into a development environment or a testing environment. That's when the DAS scanner kicks in. It tests the application as if a human user is trying to exploit it. It will basically get the UI. It will basically fire some exploits on the UI from the browser. Right? It will try to hit some APIs by trying to push some pass some malicious payloads to see if your application is compromised, if it can return something which is unexpected, right? So those kind of things happen in a dash scan. It actually dash scan happens over the live application running in your lower environments, whereas the dash scan happens over your code. It look at your code lines of code and understand where are your weaknesses.
Very clear. Thank you so much. Very
No
clear.
problem. Any other question?
Regards secrets management, what exactly mandates anything like what kind of questions can I expect from secrets management where I should know it's stored there or it is the tools are used.
Generally, they don't call out any tool names in the question. So, but they give you a scenario. For example, they give you a scenario saying that Charlie is building an application, and the application has to talk to a database, and the backend service have a property file with hard-coded credentials, uh, right? And then this after the scenario, they give you a bunch of questions. What are your best practices in terms of addressing this bad way of working? Then they give you some scenarios saying that the secrets can be put into memory of your application, right? Or the secrets can be put into environmental variable of the infrastructure running in your application. Or the secrets can be put into a key vault, a third-party key vault like HashiCorp vault. I mean, they will not call out the tool
Yeah.
name, but a third-party key vault solution. And then the secrets will be fetched in runtime at the time of need, like, or none of the above, right? These kind of questions you can expect. The obvious choice is that you have to ensure the secrets are externalized. They should not be part of your application. They should be present in a key vault, and then the secrets are rotated regularly every 90 days or 60 days, right? Those kind of best practices have to be incorporated in the key vault, right? So, yeah.
And how are the access to the secrets managed? Like who has that privilege or authority or something? Like in terms of
Yeah,
access?
they can also go to that level of extent also. So so generally, right? If the application, again, it's a shared responsibility. It's there's
Okay.
something called segregation of duties, correct?
Right. Yeah. So
So your developer should not have any access to production secrets. They should not even know what are the production secrets.
Right.
They should only be knowing a URL where they can go and fetch the secrets. That's it. And they will not even see what is the secret, what is the value of the secret. That's how the segregation of duties has to be incorporated. And you can expect questions around those. They don't call out what is segregation of duties, but keeping in mind this concept of segregation of duties, they may ask you, the developer has written the code in the development environment and they know the secrets for the development environment. But then in the production, the secrets have been externalized. They put it in a key vault. Can the same developer are the same developers allowed to access the production code or production secrets? Something like that. You should be
Right.
able to say that developers should only have access to development secrets. Only the support engineers or the people who actually run the operations of the application should have access to the key vault, but no developer should have access to the key vault. Keeping in mind the segregation of duties concept. So that's how you can expect and that's how you can answer.
Right, right. Yeah, because I mean, generally you see those questions on that least privilege, and you have this hashing and encryption and all those things they're pretty much centered around that. Depending upon how they are accessed, and so I was thinking maybe there is something where, yeah,
Yeah, right.
display. Yeah.
So as a best practice, right, even the support engineers who have access to the key vault, they should also get just-in-time access. They cannot have standing access, right? When I say just-in-time access, if a support engineer needs to have access to a key vault to get a secret, then the support engineers may have to go through an authenticator process or an additional request process where they request for additional access to the key vault for a period of 8 hours or so. They get access for a very specific time. They check out the password and then they do whatever they have to do, and then the password gets rotated, like a PAM system, right? The support engineers used to have to use PAMs like systems to basically access the key vaults to basically fetch passwords. They should not directly have access to the key vaults. That is also an extension to what you're actually asking. So that is one of the best practice to do it. So you can also expect questions around those aspects.
Yeah, mostly these used to be very secure in terms of that version control, right? Particularly when people used to, code and then maintain the versions, and then people going in and out of it and having a control over that was very, very important. So,
Correct. Yeah.
now this context of GitHub and other things, this is something which will be mostly the developers and the people will be constantly changing the process of DevOps or DevSecOps. That is very, it's a continuous change and right process. That's why I was, yeah. Okay, I think that helps me. Thank you so much.
Yeah. Considering the time, I will move forward.
Sorry, I'll take
Yeah.
only 1 minute. Regarding the secret management only. Earlier, I was just thinking that secret management is something which is individual user having a credential of privileged access with the defined role. So is my understanding correct based on what you said about the separation of duties or roles which like development people should not be having access to the production environment. So is that the secret management you're talking about, or is there any other different aspect where I am not understanding correctly?
No, this secret management in specific talks about how the secret software applications are managed and maintained.
Yeah,
Like you use
secret
service
again. Yeah,
accounts.
I want to
You
understand what
use,
is the secrets you are referring here.
for example, let's say you have a three-tier application, right? You have a UI, you have a service layer, right? And then the service layer communicates to database. Now, in order for the service layer to talk to the database, it needs to talk to the database using some kind of database accounts, right? Database user and database password, correct?
Correct credentials. Yeah,
Yeah, credentials to the
yeah,
database.
yeah.
Those database credentials cannot be hard coded in the code. It has to be
That's what.
externalized, maintained in a key vault. That's
Correct.
what I'm saying. The secret
Yeah,
management. Yes.
understood. Understood. Yeah, clear. Thank you.
Okay. But what you are saying is that will fall into the IAM domain, identity and access management, privilege access management. All that is a different story altogether. That is how basically every employee or a contractor within an organization get access to different systems. So
Correct.
that is a
Yeah.
different discussion altogether.
Okay. This is different. Okay.
Yeah. Okay, I'll move on. Next, we have to jump into threat modeling. So, threat modeling is a concept. I think we have discussed very briefly in the previous slides. Threat modeling is a concept where you kind of at the design stage itself, you sit together with different stakeholders like your engineers, your product management team, your architects, your security team, all of them. We all conduct a workshop together and understand what is your application, what are the different components of your application, what are the different interactions within your applications, right? And what are your trust boundaries of your application? Uh, what is external facing, what is internal, right? All of these different things that you understand. And then you sit down and understand what are the different threats that you see here. For example, somebody compromising a vulnerability on your front end application and right and performing in cross-site scripting, right, is a threat and which could lead to some risk. For example, like the confidentiality breach, because your sessions can be hijacked, right? That's a confidentiality breach, right? That's the risk that you see here. So the threat here is somebody being able to perform an cross-site scripting by exploiting a cross-site scripting by exploiting a vulnerability, which is nothing but lack of input validation. And the risk at the end of the day is your confidentiality is breached. So that is the kind of assessment that needs to be done at every component within your application. So basically, you cannot do it on your application at once. You have to break your application into several small chunks, and at every small chunk, you have to do this assessment. So that's called threat modeling. There are various frameworks. So in the first stage of the threat modeling, you basically draw out, right? Like I said, what are your trust boundaries? Who are the personas? What is external facing? What is internal facing? What are the different components? How does these components interact with each other? All of these things you have to draw it out, put all of the transitions, put all the connections, and then you'll have to go and use a framework. There are multiple frameworks that I'm going to talk shortly, like Stride, Dread, etc. You'll have to use any. You can use any of these frameworks, or you can use a combination of these different frameworks. Or some organizations use their own frameworks. But for the purposes of CISSP discussion, we will restrict our discussion only to Stride, Dread, Pasta, and all of these well-known threat modeling frameworks. So you can use these frameworks to quantitatively go through every risk profile and identify what is at risk, and then based on that prioritize those risks and start working on putting some controls around mitigating those risks. So that is the whole process of threat modeling. And at every stage we ask ourselves a question, and again you can read this in the threat modeling manifesto that's available out. At every stage we have to ask ourselves, did we do a good job? Did we identify every possible input, every possible external output, right? Did we look at every possible threat? Did we look at every possible risks that we may face, and did we properly prioritize the risk based on the impact, right? All of these different things we'll have to consider, and then we have to ask ourselves a question and then move forward. Just one example of how a threat modeling look like. For example, let's say there's an entity user talking to a web app, and the web app is talking to a database, right? So we'll have to draw out on all of these different things, like a user may send an HTTP request or an HTTPS request. It may get an HTTP response or get an HTTPS response, and the web app can query the database, right? Now, based on this, I can see a big risk here, right? Because when a user is using an HTTP request to a web app, and because this user is coming from the internet, somebody can sit in between and can hijack the traffic, or can just do a man in the middle attack, understand what is the request, what is the payload. They can look at the data that is going into the web app, which is a confidentiality breach, right? Yeah. So, for example, you see it's here, eavesdropping and tampering the transmission of data in the network, because of the fact that the user is able to use an HTTP request to talk to the web app, right? So that is the kind of activity that we do to understand all the different things, that is all the different flows, and you kind of prioritize the risk. At the end of the day, you kind of come to this conclusion. You put this table together. What is a threat? Under which category that threat falls under, and what is the risk? Is it high or medium or low? Based on this, you'll have to start working in your design itself to fix those and address those. And to do this, like I said, you can use various frameworks. You can use Stride, which is a Microsoft proprietary frame. It's an open source framework, but coined by Microsoft. And then you have Dread framework, you have Pasta, Octave, Vest. Most predominantly, I see everyone using Stride and Dread. These are also I've personally I've not seen this use anywhere, but then we don't know, it can be, could probably be in use somewhere, but uh, just having an understanding of the categories inside each inside each framework will really help, because you can expect a CISP question saying that what are the different uh, threats within a particular threat model like Stride, and then they can say spoofing, tampering, repudiation, and then they can write exploitability there, right? You should be able to identify what is the one which is not belonging to this particular framework. So just take a look at Stride and Red, and you can skip the rest, but then at least these two are important. So there are companies where they use combination of both. They use Stride and Red in combination. You can actually effectively do a very quantitative assessment. So Red will help you score. Stride identifies what is the element of compromise here. So that way you can map them both together and have a quantitative assessment of this. So these models are important. So for the CISSP exam, please take a look at these models and understand what each means. So basically, I'll just give an example of Stride. You can look up what is Red and all of that. Spoofing means anything that relates to confidentiality breach is spoofing. That means it's an impersonation kind of a thing. Somebody impersonating someone to compromise something to get some information. That is spoofing. It at the end of the day, it leads to um, identity theft, identity misuse, right? Impersonation, etc. Tampering is where there's an integrity issue when an attacker is able to modify the data in transit, modify the data at rest. That's when the tampering is impacted, right? Repudiation is that fact that you should at any point in time you should be able to locate who is the attacker or who is the threat actor that's involved in this entire attack path. You should be able to map it back to the user, right? If you're unable to, then it's a repudiation issue. And then information disclosure is when attacker gets hold of confidential information like the database, or maybe some property file containing sensitive information, or some key vault containing key secrets, etc. That is a confidentiality issue. That's where information disclosure aspect comes into the picture. And then denial of service is where an attacker is able to uh, pass in some heavy malicious payloads to bring down the system and compromise the availability of the system for a particular time. So that's called denial of service issue. And then we have elevation of privilege when an attacker from a low privileged user gains access to a high privileged user, or some high privileged principal. That's when the elevation of privilege is impacted. So uh, that is how you look at Stride. There are like similar way we have Dread. You assess these aspects. What is the damage potential? What is how complex is it to reproduce? How complex is it to exploit it? Who are the affected users? What is the how often this can be discovered? Right, all of these aspects, Dread model covers it. Most predominantly used to Stride, but then some of the companies also adopt using Dread. Some companies adopt both using Stride and Dread.
So one query over here.
Yeah.
Is it possible that we get some sort of document where it says that about a spoofing CIA is which is the major what I get the failure when spoofing happens?
So when you have spoofing, generally you can compromise both confidentiality and integrity both.
Yeah. So I think
Right.
I read somewhere that this
Yeah.
was a scenario which I read it. So when you said, I remember that. So do we have somewhere or any website where we can just go and check if tampering happens? Of course, it is integrity issue.
Hmm.
Repudiation happens. What is that availability or it is confidentiality? Not very much sure.
I mean, not everything maps back to CIA,
Abstract,
but
right?
then yeah,
Okay. Okay.
yeah,
Mm.
but then predominantly they do. For
Okay.
example, denial of service is an availability issue. Information disclosure
Availability issue. Correct.
confidentiality,
Correct.
right? Elevation of privilege, you can do both confidentiality and integrity. But
Integrity both.
once,
Yeah.
right,
Correct.
right,
Sure, sir.
yeah. So I'll move forward. I think we are short of time. I think we're almost past time. So let's do a quick quiz and then we'll come to the closure. So your team is developing a new payment processing module for an e-commerce platform. During a threat modeling session, you identify that an attacker could manipulate form inputs to bypass payment verification and gain unauthorized access to premium content. Which tried category does this threat most likely fall into?
Tampering.
Anyone else? Yes, you're right. Tampering. So basically, the attacker is able to modify something, right, and compromise the integrity of it, right? That is why it is a tampering issue. So you can expect these kind of questions a lot in the CISSP exam. So you should be able to map it back to any of the category within Stride and understand why it happens. And then the next question is, your company is designing a cloud-based document storage system. A threat model reveals that a user could download another user's private file by guessing URLs due to poorly implemented access control. What should be your primary mitigation strategy?
Implement URL encryption.
C. Apply strict authorization checks.
Okay, anyone else?
I'll also go with C.
Yeah, C
Yeah,
is the right answer.
C is the
Yeah, you should ensure that every request is authorized. You have strict authorization controls in place. This type of attack is called IDO, which is insecure direct object reference, which you predominantly see everywhere. So you generally on the URL you see numbers, right? By just changing the numbers and playing around with the numbers, you're trying to see the change in the web pages. So that is the kind of issue that we're talking about here. Okay, next one. A cybersecurity organization makes use of a significant amount of COTS software. A recently discovered significant buffer for there is a significant buffer overflow vulnerability in the code. What is most likely way that this company can get this corrected? What is the most likely way that this organization can get this corrected? So it's the COTS. The one of the important thing to notice COTS. So how many of you know what is COTS here?
it's off-the-shelf software kind of.
Yes, it's an off-the-shelf software.
Actually, yeah,
It's
off-the-shelf.
it's a third-party software that you procure, right?
Yeah, yeah.
So what can be done here in order to fix that vulnerability?
It's vendor task, so vendors would do
So
patch.
notify the
So
vendor and
B,
patch.
B I think is the correct
Yes.
answer.
Yeah,
It's
B
B.
is the correct answer.
B is the
That's
correct.
correct. B is the correct answer. So you'll have to work with the vendors to have the patch rolled out for this. Okay, moving on. So because we have moved into this, one of the important aspect is to understand uh, different ways of doing a computation analysis of your threats, right? Of your vulnerabilities, basically. So one of the way is CVSS, right? So CVSS 3.1 is the prior computational model. CVSS 4.0 is the latest one. These are the different parameters on which a CVSS score of a particular vulnerability is calculated. For example, let's say you've received an cross-site scripting vulnerability issue, right? You saw that issue. Then you should be able to fill the CVSS4 calculator and fill all of these details, and you should be able to get a score, whether it is high critical, medium critical, low critical, right? Or informational. So you should be able to get that score. So Anyone who's looking at this slide can basically open your browser and search for CVSS4 calculator. You get the calculator, and then you can play around with the calculator. You'll have to basically fill out what is an attack vector. So basically, an attack vector says when a particular attack happens, whether the attacker can orchestrate the attack from the internet, or should the attacker be within the network to exploit some vulnerability within an application, or should the attacker be within the system where only then they can exploit the vulnerability. So that is called an attack vector. So there are multiple values to it. One of the value is network, one of the values adjacent, the other value is local. So depending upon whether it's an internet attack or whether it's an adjacent attack which is within the network, you will have to fill up that value. Likewise, then attack complexity is present. So attack complexity is where you basically have to understand once the attack vector is determined, what is the complexity to perform this attack? Is it easy to do this attack, or is it complex to do this attack? And then attack requirements. Attack requirements is the parameter where you decide what are the preconditions that an attacker needs to do in order for this attack to be successful. For example, if you have to say that an attacker has to bypass MFA, only then they will be able to compromise this particular vulnerability, then that is an attack requirement. Then the possible values for this is attack requirement present and none. And then privilege is required. Does the attacker need any privilege, whether they need a low privilege user or a medium privilege user or high privilege user? And then the last one is user interaction. User interaction is a factor where you see whether an attacker uh, needs to have UI interaction to the application, or can they simply fire an API and then get exploit this vulnerability. So if you need a UI access, then use or maybe if there is a third, if the attack depends on somebody clicking on something, right? Then the user interaction is present here. For example, you send a phishing link to an attacker sends a phishing link to somebody in the organization, and that user has to click on that link for this attack to be successful. Then the user interaction has to be present. So these are the exploitability metrics that you'll have to fill in when you have to compute the score for your vulnerability, whether it's high privileged or medium or low. Likewise, there are impact metrics. After this attack is successful, if you are able to compromise the confidentiality of the system, what is the confident whether you are able to confidentiality whether you are able to compromise the confidentiality of the system, and the confidentiality score is high, medium, and low. For example, if you're only able to compromise small piece of information within that system, then you mark it low. If you're able to compromise huge amount of information, then you mark it as high, right? Or if you say there is no confidentiality impact, you mark it none. Likewise, integrity issue. If there is an integrity issue, you mark it low, high, or none. Likewise, availability. And there is something called subsequent system confidentiality impact or integrity or availability. What it means is beyond the system, if an attacker is able to navigate and compromise some other system that is in line of sight with this current vulnerable system, then you can fill subsequent system confidentiality, integrity, and availability. That's when you get a CVSS score, right? And you can use the CVSS score to prioritize the risk remediation aspects. So I would encourage everyone to just go through CVSS calculator, 4.0 calculator. You can find it online. Just type CVSS 4.0 calculator. You will see how to compute this. And you can also go through the help section of it under each category. You will be able to understand what each means. Whenever there's a vulnerability identified in any of your software, you'll have to use this CVSS scoring to rate the severity of the vulnerability using this calculator. So you can expect some questions around this in your CISSP. Any questions on this?
Yeah, in this, yeah, I'll be interested to know what is relating to this particular weaknesses and vulnerabilities. What do you see is the most common occurrence of the current trends in hacking or data breaches? Where do you see most weaknesses, and where are they referenced? If in case I want to research on that area, so that potentially there might be those questions which I'm ignorant, right? So I'm looking at that. What is occurring mostly now? Where do they see the potential to, find the weaknesses?
I mean, that's a hard to answer because I work in organizations where I tend to fill up all of these things. Like every vulnerability, you get to fill all of these things. It's not see, for example, there are cross-site scripting issues, right? Generally, the cross-site scripting issues, for every issue, you have to fill all of these things. Exploitability metrics, you have to fill in, right? But when it comes to the CIA trade, for cross-site scripting, it's only confidentiality issue, right? But then when you have a DDoS attack, or when there is a remote code execution vulnerability, then all of these three are impacted. Confidentiality is impacted, integrity is impacted, availability is impacted, because you are able to inject the code and get some reversal, and then using the reversal you can basically compromise the entire system, right? So it's very, if I answer that, it would not be an accurate answer because it's very hard to say that what
So,
is the one area that I can focus.
yeah, so my question was this in a pretty in generic sense. We hear of a lot of the truth doesn't come out. The organization definitely doesn't want to expose where the lapses were. So there is some area where which is very technical, and then that is something which is known to the organization. It's just that they mentioned that the data breaches happened or something as ransomware attack and this and that. But then we don't get to the truth of it. But in terms of in this perspective, where was the weaknesses that were or the lapses were in terms of the organizations, how they controlled, and that was
Yeah.
something that was exploited. That's what I was asking in technical terms.
Okay, so basically let's say you see a news somewhere, right? Somebody got impacted by something, right? And they publish something. They publish a CVSS number, CVE number, or it's called CVE ID. It starts with CVE hyphen and then some followed by some number, right? If you open the CVE ID in, and you can go to nvd.org and search for that CVE number, you get to see all of these data filled, and
Okay.
you get to see a number there, whether it's high critical, low critical, or medium critical. I can actually show you a small example quickly for the purpose of everyone. So let's
Yeah,
say
because I
there
didn't
is,
work in it, and then these are new terms that might come up, and that's where we, miss out on.
see, for example, this vulnerability is released in March 2024, 25th, right? So now if you go, there are CVE numbers that are released. If you go search for the CVE number, you go to just search this way, right? You go to NVD. NVD is the National Vulnerability Database, right? You can see the score, CVS score 3.1. See, all of these things are filled: attack vector, attack complexity, privilege required, user interaction, scope, confidentiality, integrity. But this is computed on 3.1 calculated. Now we have C3 4.0. So going forward, you will see all the CVs published with 4.0 calculator, right? So whenever you read any article of any vulnerability, right, try to look what is the CVE for it and search for that CVE, and you'll be able to know what is the severity of that finding.
Okay, thanks.
Okay, moving on, these are some of the top 10 security risks that you see. Uh, I I would recommend everybody to go to OAS top 10 security. Just search for OAS top 10 security and understand at least the top 10 security. What are the different issues that you see? So OAS does a research frequently, and then they say, hey, what are the top 10 common mistakes that I see day in and day out? So they publish those mistakes. So these are all the different issues that WASP thinks that are commonly made across all the organizations. Authorization issue, not having proper authentication, right? So now you can actually see the 2019 is when I think they last published. 2023 is when they published API security issues. So sorry, I think these both are for API only. So 2023 is when they've updated this 2019. So you can see all the new updates. They changed the top 10. So go through all of these top 10 to understand what are the common top 10 mistakes that are made on API development or in general application development. Okay, so and then I think this is the last almost last slide. Some secure coding practices. Everybody knows all of these secure coding practices, right? So ensuring input validations are done and output encodings are done. RBAC is maintained. Principle of least privilege is followed when you're writing your applications. Proper error handling, not giving out too much of error details. Ensuring data at rest and encrypt transit is protected. Session management is done properly. And then ensuring the libraries and APIs that are being used are used properly. We have to ensure that the third-party libraries that we use having proper security patches updated with. And then logging and monitoring, ensuring all the logging is done properly, and then the logs are stored, and then they're archived, and then they're pushed into SIM, right? Yeah, these are some API security related things. From again picked up from OWASP again, OWASP top 10. Authentication authorization issues, input validation, rate limiting, data exposure, transport security, etc. And then finally, last topic, software-defined security. I think most of the organizations now have moved out, right, from traditionally managing infrastructure and cloud-based configurations from the UI. Rather, now they're using policy as code. They're using infrastructure as a code to maintain the entire infrastructure, like using Terraform, Helm charts, etc. So when because of this switch, we are getting a lot of benefits of this because uh, a lot of scalability issues that we had in the past are now resolved. All of the deployments are being scaled within a span of seconds because you have flexibility in the code itself to be able to make the change. And then the rapidness at which we are able to put in security controls has improved a lot because of infrastructure as a code, because everything is managed through code and you just have to change the number in the code and then or the policy in the code, and then it gets reflected across all the deployments at one shot. For example, if let's say you had 400 different deployments, if you have to change a single firewall rule, you have to go through all the 400 deployments and change that setting. Rather, if by the infrastructure as a code, by just changing at one place, the change get rolled out and seamlessly implemented across all of the different deployments, right? So you we kind of gain benefits of this software defined security methodology. Uh, we are able to now write the entire deployment as code. We are able to enforce some security controls dynamically as and when needed, without the need to go through every single deployment. And then you can integrate your infrastructure as a code with all the security scanning tools, which will flag errors in your infrastructure, like using weak passwords or maybe store using default configurations, etc. It can identify and flag those issues. And then you get a centralized control of all the deployments at one place. That's the benefit of software defined security. So I would also encourage everyone to understand a little bit about this software defined security and just know some significance of this, because you may expect some questions around this. So lastly, with this quiz, we will call it for the day. So a developer dynamically generates HTML pages using user comments stored in a database. The following line outputs the comment in a raw HTML. So what OS security coding practice is being violated here? Anybody? Okay. So here, this particular component, user underscore component, is being fetched directly from the database.
So access
So
A.
sorry.
Its output encoding is missing, leading to X cross.
Exactly. Exactly. So when you're fetching something from the database or from any third party, even from the known trusted sources, you have to do an output encoding. You cannot just directly put it on the console because it can lead to a cross-site scripting, a stored cross-site scripting attack. Right.
Yeah.
Next one. Then what type of security issue arises when an attacker can reduce a more sensitive piece of information by analyzing several pieces of information classified at a lower level? This is interesting.
Yeah,
So,
it's multi-level security.
okay, anyone else? So, if you understand this question,
think interference.
sorry,
I think interference can be done.
it's inference. You're right. It's inference. So the reason why it's inference is because an attacker can look based, for example, let's say an attacker gained access to a low privileged user, right? With that low privileged user, the attacker is scouting for information, is doing a reconnaissance, and he gets to know some information. Based on that information, he tries to escalate himself to a higher privileged role. So that is called inference. From some low information, you can gain access to high privileged information. That is called inference.
Oh.
Moving on, Kerry is analyzing the application logs for a web-based application comes across the following string. What does it mean? Okay, what type of attack is going on here?
It's a password, so it's a session hijacking or a brute force. It could be B or D, but
Yeah, anyone else want to try?
It's password related, so I will go with the brute force attack.
Yeah, so this is a very interesting type of question that you can see expecting from CISSP because they're basically confusing you with this word PASSWD, but
Okay,
it has nothing related to that. It's basically a directed traversal attack,
direct
right?
filter. That's the same. Okay.
okay.
Yeah. So that's all for today. Thank you so much for your time. And
Thanks, Abhinay.
yeah,
Hey, Abhinay, if you can just show us the CSA Bangalore chapter homepage, I just want to brief the participants about the activities
Just
happening around.
Sai, just
Sure.
want to check with you on that. So, what is the standards, in the software development and testing part of it, with testing data and putting the, requirements for machine learning and AI and all these people get the data and they want to look at quality data. So, what is the masking or obfuscation standard here in terms of that was one. And second thing is the current domains mapped to CSF 2.0 on the on the NIST CSF?
okay. Let me take the first question. First one is about you're talking about data anonymization and data masking, right?
Right, right.
So honestly, I'm not very familiar with what are the standards. I can look up and maybe give you an answer.
Okay.
I'm not really aware of it. Sorry
Yes,
about it.
not a problem. Yeah,
And second, you're asking about NIST CSF, right?
yeah, CSF 2.0 and so yeah.
Yeah, I think NIST CSF 2.0 is a conglomerate of all the different standards together, and they brought down together into one standard, right? Is that the one you're talking about?
Yeah. So is it mapped to the current, across the domains understanding of different controls and do you see any match or is it to the past CSF? There's a bit of cross across NIST and frameworks and CISSP, right?
Even I'm not sure about that.
Oh,
I've
okay.
not done that level of research. Sorry.
Okay, okay. Thank you. That helps. Thank you.
Okay, sure. Yeah, go ahead,
Hey,
Seema.
everyone. Thank you so much. I hope you had a wonderful session. So if you can see this we any doubts you have, you can reach out to us on support@csabangorechapter.com email ID, and we will be happy to respond to you. Just wanted to brief about the activities happening around CSA Bangalore chapter. So we are having a monthly event which is happening on 3rd of May, which is at KPMG office of Bangalore, EGL office. You can, if you anyone is interested, you can participate in that. We have also an annual event happening around 4th of September. So that would be a good opportunity for you all to interact with the CXOs and CIOs who will be coming, and you can get their insights on how the cybersecurity trends are today and now trending topics which are happening around the globe. You'll be able to get insights on those, and also you'll get an opportunity to network with individuals or professionals coming from different organizations and different sectors of cybersecurity. Also, if you are interested to give a speech or something, you can certainly reach out to us at support@csabangorechapter.com. We'll be happy to take it forward. We are having several other workshops also on the annual event. You can look into that as well. You or your team hold together, if you want to come to the event also, we can arrange for special passes for that as well. um, One more thing I wanted to mention is, if we are looking for sponsors as well. If your organization wants to have a demonstration of a product or which you are building or something, and you want clients or networking opportunities, this would be the right opportunity. You can get in touch with us. We'll be happy to help you. Other than that, the rest of the domains which we had the CISSP webinars, you can, if you're not enrolled for it, we have on-demand videos available. You can certainly go through, register for it, and we will be giving you an access for that. Other than that, there is a mock test as well. Since we have completed all 8 domains, there's a mock test available. You can go through that as well. Um, any other queries, you can reach out to us on support@csabangorechapter.com. On that note, I would like to close for the day. Thanks, everyone. Thanks for joining.
Thank you all. Thanks.
Thanks, everyone. Bye.
Vinay, just one small query.
Yeah.
Is there any way I can check the reputation of IP address and website?
Yeah, there are multiple sources like VirusTotal, etc. You can use that.
Virus total.
check. Yes.
Virus total. Yeah.
We can discuss this offline now. Vivek, you can ping me on separately. We can discuss.
Thanks,
All right.
everyone.
Thanks, everyone. Bye.
Thank you.
Have a
Take
nice
care.
day. Happy
Thank
weekend.
you all. Bye.
Thank you. Thank you.